VLSos here. This is a video lesson on even and odd functions. The words even and odd mean something when we apply them to functions. They describe an attribute or a quality that a function has. But what does it mean when we use those words? We're going to investigate a function f of x is equal to x to the fourth minus 2. And I'm going to make a quick sketch. This is not a parabola, but it looks like a parabola. This is the curve x to the fourth moved down 2. And of the many things that we could say about this function, just simply looking at its graph, one thing that we might be able to prove is that it has y-axis reflection symmetry. It looks like it does. If we reflect one side across the y-axis, it'll match up perfectly with the other side. But graphs are just visualizations. We can't formally justify something by looking at a graph. And if we can say or justify that it has y-axis reflection symmetry, this is what we mean by being an even function. So how can we prove that a function is even, that it has y-axis reflection symmetry? Well, we look to the algebra of transformations. What it means to be even is if we can take a function and show that it's equal to itself after a y-axis reflection transformation, which means making x negative or the horizontal variable negative, then we can say that it's even or prove it. With this function, it means setting up the justification that the expression x to the fourth minus 2 is equal to itself after making x negative. We'll put a question above that equal sign. If we can simplify it and observe that those sides are indeed equal to each other, then we have proven that it's even. I could add 2 to both sides and then think the fourth power of a negative number. Well, that's a negative that's going to cancel out by multiplying by itself, and then it multiplies by itself again and makes it negative, and the fourth and last time turns it positive again. So an even power of a negative number will cancel out the negatives and make it positive in the end, which means that it's equal to its other side, x to the fourth. So this is obviously true, and we have just justified, or therefore, the symbol of 3 little dots, f of x is even. So what about odd? A function that is odd has 180-degree rotation symmetry around the origin. And we can accomplish rotating something around the origin 180 degrees by reflecting it over both the x and y axis, or a horizontal and vertical transformation done at the same time is equal to 180-degree rotation around the origin. The transformation of that is that the function will be equal to itself after making x negative, that's the y-axis reflection, and taking the negative of the entire thing, that's the x-axis reflection. The transformation for odd can also be written this way. The negative of the function, if it is equal to itself after making x negative, then that proves that it's odd. So let's work with a function. We'll define g of x to be the cubic function. And the cubic function's graph looks like this. And by observing the graph, it looks like if we rotated this branch around 180 degrees, halfway around, that it would line up on this branch here, so it looks like it has 180 degree rotation symmetry around the origin. And we could list that as an attribute. And if it does, then we would want to say, or we could say that it is an odd function. But can we prove it that it's odd? Well, proving it would be setting up this algebra and then demonstrating that it's true. Setting up that algebra means that I take the expression for the function and set it equal to itself after making x negative and the entire function negative. Those two transformations. Is this true? We'll put a question mark above the equals. Well, we're going to simplify the right side. A negative number cubed, that's times itself an odd number of times. So the first time we multiply the negatives, they'll cancel out and make it positive. But the last time we multiply, for the cube, we multiply one more time and turn it back negative. So a negative number times itself an odd number of times remains negative. But then we have this additional negative out front to turn it back positive, which means that the negative of a negative cubed is positive, and in this case equal to the other side. So it is true when we tested that it was odd, that it ended up being odd, and we have proven, we could say, therefore, G is odd. Few functions are either odd or even. And the words odd and even to describe this kind of symmetry in the function comes from the fact that most functions that are even have to do with an even exponential power, and most functions that are odd have to do with an odd exponential power. But there are functions like the sine function that can be shown to be odd that have nothing to do with powers. So if you find a function and can say that it's even or odd, you know something very important about the graph and the nature of the function. But most functions are neither even or odd. It's kind of a special property.